Thanks for clicking on this video. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. Now, here we're talking about volume on base where the cross sections are circles. Now, if you haven't watched the video where we go over volume on base with squares and rectangles, I suggest you stop and watch that video first, because some of what we're going to be talking about assumes that you've already seen that video. So once you've gone and seen that, come back and we'll go over this one. Okay, so here we have the region of x squared plus y squared equals 1, whose cross sections are perpendicular to the x-axis and are semicircles, whose diameter is resting on the base. So if I draw this picture, here's our base. We've seen this before in the square and rectangle video. Now here are slices like this, and this is a semicircle. So it's like that. Now from the previous video, we saw that, all right, dx is the thickness, and the base length is 2 square root of 1 minus x squared. Now what we need to do is we need to figure out what is the area of this. Now this is a semicircle. So the area of a circle is pi r squared. So a semicircle is 1/2 pi times r squared. So the radius is going to be half of this because this is the diameter. So half of that is going to be 1 minus x squared squared. And since it's volume, I want it to include the thickness. So that is dx. So the square root and the square are going to cancel out. The 1/2 pi, that can go out front. So 1/2 pi, or pi over 2 if you'd prefer, that's fine, times 1 minus x squared dx. And there is our integral for that one. Number 2, here we have the region between y equals x squared and 2 minus x squared. And this is -1, and this is 1. So here we've got dx as our thickness, and as we saw in the previous video, the length from one curve to the other is 2 minus 2x squared. Now here, the circles whose diameter are on the base, so actually it looks like this. So the circles are actually kind of passing through the base. So we want to find the area of this circle where we have 2 minus 2x squared as our diameter. So the volume of this slice is going to be pi times the radius, which is 1 minus x squared dx. Again, 2 minus 2x squared is the diameter. So I had to divide it by 2 to put it in for pi r squared. Now we have to add up all these volumes. So pi goes out front, -1 to 1 of 1 minus x squared dx. So there is our volume for that. Number 3, we have the region of 2 square root of sine x. So that's pi. And so here, quarter circles whose radius is resting on the base. So this actually looks like that with a thickness of dx. So this is 2 square root of sine x. Just like that, 2 square root of sine x. So the volume of this slice, now this is a quarter circle, so it's 1/4 pi times r. Now in this case, I don't have to divide by 2 because this is the radius itself. So 2 square root of sine x squared dx. Now what's going to be nice about this is that when I square the square root, it goes away, but when I square the 2, it becomes 4. And that's going to cancel out the 1/4. So I will have a pi out there, but that's it. And so the integral is from 0 to pi dx. And then finally, the last one, we have this region from 0 to 2 on the x and 0 to 16 on the y. And we have this slice. It has a thickness of dy. And so we have 2 minus the cube root of y over 2. Now, this right here is the base of a semicircle again, just like number 1. 2 minus the cube root of y over 2. And that is our diameter. So when we find the volume of this slice, we have to remember this is a semicircle. So 1/2 the whole circle, 1/2 pi r squared. So I have to multiply this by 1/2. So 2 minus the cube root of y over 2 squared dy. Now I'm squaring not only this, but the 1/2. So I have 1/8 pi 0 to 16 of 2 minus the cube root of y over 2 squared dy. And so there is the integral for our volume. Thanks for watching. If you like this video, click the like button. And if you want to see more, hit the subscribe button. To subscribe to this channel, to support the channel, click the links down below. Thanks for watching. And remember, the best way to understand something is to do it.